First problem. Describe the end behavior using limits.
So I believe since it's on since it's a part of
The limit of what as x goes to what?
as x goes to infinity, x will be or f of x will equal infinity.
Well, almost, not quite. There's two end limits. One is as x goes to infinity, the other is as it goes to negative infinity.
Yes.
What's the only term in this polynomial that affects any of that? It's not f of x. We don't need to go through. It would be hard to figure out what happens to f of x if we let x go to infinity. We're going to have an infinity there, an infinity there, an infinity cubed there. So there's only one term that matters. Which one is
it? The first term, the x to the fifth.
Yeah. So this is really the proper answer for both of these. And what happens to x to the fifth as x goes to positive infinity?
It's positive infinity.
What happens to x to the fifth as x goes to negative infinity?
Negative infinity.
Correct. How many real zeros can this function have?
5.
Right. It can always have, it doesn't have to have 5. Well, it kind of does, but sometimes two of them are the same. And so they'd say it has multiplicity of 2. But yeah, you're always capable of having as many real zeros as the maximum degree of your polynomial. How about extrema? How many extrema can we
have? 4.
Yeah, and if you ever forget that, a good little test is, well, let's look at y equal x squared. How many extrema does this have?
1.
Right. In other words, by checking this function, which you know for sure how many extrema it has, it's always one less. Now, if I was dealing, in other words, a typical x cubed function might look like that. It's going to have an extrema there and an extrema there, but it's always at most one less than the degree of the polynomial. Find the real zeros. Now, for this, we do need the whole function, so let me do something here. You write it. So let's start with this. What's the first thing we're going to
do? Factor out the x cubed.
Okay, so what do I have?
5x squared and 3x to the first, or 3x plus 2.
When you factor out, what did you say again? Factor out x cubed, what do you have? When you're going to factor something out, always write it first. And then figure out what you have left over. What's left over?
X squared plus 3x plus 2.
Okay, what's the next step?
Find the factor of x squared plus 3x plus 2.
Okay, what's that?
X plus 2 and x plus 1.
So what are the zeros of this thing? If I let f of x equal 0.
-2 and -1 and x cubed equals 0.
That's the one everybody forgets. It really is. Never forget that 0. That's just as valid of a 0 as the others. How come I didn't get 5 zeros?
I don't know.
Because 3 of them are the same. In other words, that x cubed is actually x times x times x. So this has what you call multiplicity of 3, whereas each of these have a multiplicity of 1. So in effect, we did have 5 solutions. X equals 0, x equals 0, x equals 0, x equal minus 2, and x equal minus 1. You're always going to have the proper number of solutions based on the degree of the polynomial, but some of them could be multiple solutions. So is this news to, are you on spring break this week? You're not?
I start tomorrow.
Ah, okay. Because most of my Colorado students are on spring break this week.
Nice.
You start in the middle of the week on a Wednesday, huh? Is your
Yep.
is your spring break a full week?
Yes.
Oh, I was going to say, gosh, maybe Florida's getting their act together by not giving so much vacation time. That's what Saul Kahn from Khan Academy said, that the only difference between us and the rest of the world is we don't have as many school days a year as most countries do.
But we work more than they do.
That's true. We work at jobs more than they do. But the reason we're ranked 26th in the world in math and science can be attributed 100% to the fact that we only go to school 180 days a year, whereas most countries go 250 or 60 days. They go year round. In other words, having that 3 months off in the summer makes the difference between being number 1 and being number 26 in the world.
That's major.
It is major, and it's really time our country changed. That's why I said I thought maybe Florida was getting their act together, because our whole model was based on agricultural needs. Kids needed to get off in the summer so they could go work the farms, but that's not true anymore.
Not anymore, yeah.
So we really should change it and catch up with the rest of the world. Plus, there's an unbelievable amount of forgetting that takes place. Not only do kids not get that 3 months in the summer in school, but they forget half of what they learned the previous year. I've seen that over and over and over. So
True.
there's 2 really good reasons, none of which students are going to be real happy with. But if we wanted to improve our education system, that'd be a good place to start.
True.
Number 5 says, how can I tell, if I bring my picture back up, do these zeros, let me kind of draw it. I know there's a 0 at 0. I know there's a 0 at minus 2. And I know there's a 0 at minus 1. Okay?
Okay.
Now, how can I tell whether the graph goes through those zeros or just comes down and kisses it?
Cross if it's only 1, and then touch if it's more than 1.
It's got to be even to be a toucher. This has none of the zeros. That's odd, that's odd, that's odd. In other words, this has multiplicity of 3. This has multiplicity of 1, and that has multiplicity of 1. So I've got to go through the graph at each of these. An example of where it would just kiss the graph is if I had y equal x squared. Well, the 0 is x equals 0, but notice what it does. It goes down and it kisses the graph and goes back up. It doesn't cross the graph at x equals 0. So it's all based on whether each of these, what the exponent is. In other words, let's say this was a squared, like that. Then my 0 here is not going to go through the graph. It's going to touch it and go back the other way. Now, can we figure out how to draw this graph?
Um,
Remember the first question about end behavior. What was the end behavior as x went to infinity?
yeah, use the so then whenever x
We can
goes
start from the left or the right. I would suggest always starting from the left.
the
What
left goes negative infinity and the
Yeah,
right goes
in other
positive.
words, I'm starting from down there, right? That's the only real question I have, is whether to start from down here or start from up there. Well, that would indicate that the end behavior was positive infinity. We've solved and discovered the end behavior is negative infinity. So I'm going to do this. I'm going to go up to there. I know it goes through. I know it goes through there. And I know it goes through there. And I know it ends at positive infinity, like that. So if you graph this on your calculator or Wolfram Alpha, it'll look something like that. Now, granted, we didn't solve for that point right there, and that's not particularly easy to solve for without calculus. But we certainly know what the general shape of the thing is. We know that there's two extrema. Notice that when one of the solutions is a multiplicity of 3, then you're only going to, we could have had 4 extrema in this, but having a multiplicity of 3 on one of our zeros means we're going to have at most 2 extrema.
Okay.
Okay. Now, if I change this slightly to make it x squared, and I realize that doesn't fit, but let's say we came up with that as an answer, then I would, that's going to change everything actually, because that changes the end behavior to plus infinity, but I don't care, I'll still do it. In other words, now the leading term is x to the 4th, so the end behavior is positive infinity. So I'm going to come down, I'm going to go through the graph, turn back up, go through that point, and now I can't go through there. I got to bounce back up. And our end behavior would be positive infinity on both sides. But notice how we go through the graph when it's an odd number, and we kiss it when it's an even number. And even if that was x to the 4th, we would kiss it, or x to the 6th. Because all that matters is that it be even.
Okay.
All right. How am I going to determine if x minus 1 is a factor of that 3rd degree polynomial?
I divide that polynomial by x minus 1 and see if I get a 0.
That's exactly correct. Now, have you learned synthetic division yet?
Yes.
Do you find it easier or harder?
Way easier.
Yeah, well, let's do it then. Tell me what to do. What do I write? First of all, what goes in the box?
1.
Correct. What goes in the box is the solution, the real 0. X minus 1 is a factor. But if x minus 1 is a factor, that means the real number would be 1. The 0 would be at 1. And what goes across the top?
1, 3, -1, -3.
And have you learned that if you were missing one of these degrees, you would have to put in a ghost. You'd have to put in a 0. Whether you're doing it by long division or synthetic division. In other words, if we didn't have this x term right there, we would need a 0. You have to account for each degree of x. All right, now what?
I'll put a little arrow under the 1 and then make it 1.
Always bring this, whatever that number is, always bring it down below the line. That's your starting spot. Now what?
Okay. Then multiply that by 1, which will be 1. Then 4, 4, 3, 3, 3, and then it'll be 0. So yes.
Okay, so by the zero remainder theorem, that means that x minus 1 is indeed a factor of this. And what's the rest of it? In other words, if x minus 1 is the factor, what's the other factor?
X squared plus 4x plus 3.
Yeah, the beauty of synthetic division is that it gives you the other factor right there. No matter, and then, you know, if this was a fourth degree polynomial and they gave us two different factors, we'd be all set to go. We would have the top already written out and, you know, could do another synthetic division right there. In this case, we don't need to really do it because we can factor that thing. How's that factor?
It would be x plus 3 and x plus 1.
So what are our zeros?
-1, -3, and 1.
Okay.
I could do synthetic for this one and put -1 in the box.
Okay. There's actually two ways to do this problem.
Or I could plug in the -1 for x.
I actually prefer that myself. There is, no, you know what? There is an advantage of doing the synthetic division. And that is that if it is a zero, you'll have your answer. Whereas if we just plug in 1, in other words, if I do this, I might determine whether this whole thing is equal to 0 or not, but it doesn't let me do anything after that. In other words, I could say yes or no, that f of minus 1 is, you know, what that number is. But if it happens to be a 0, I'm going to wish I did it by synthetic division. Let's just see quickly if it is. I want to put the plus sign in there. Did you take your dog to Porter? Or, excuse me. You're not. That was my last.
Yeah, that's my dog in the background.
Oh, I had a previous appointment with a guy that was in Puerto Rico. And I lost my train of thought for a second. So I know you know how to do these, so I'm just going to do it real quick.
Okay, 1 second. I'm going to go get my dog to stop.
Okay. Okay, so after doing the synthetic division, I get a -1 there.
So then it will be -3x cubed plus 4x squared minus 2x plus 4, then -1 over -1.
Not -1 over -1.
Wait, no, never mind. My teacher said that she just needs the leftover to not do that. She said that just the box -1 would be the answer.
Okay.
She said.
Notice well, it's actually -1, and what we're really dividing by is the factor x plus 1, right?
True.
So the remainder is the number divided by what you were dividing by. Now notice that evaluating f of -1 using synthetic division didn't give us an answer. Whereas if we'd have plugged it in, we would have had at least a number. So there's advantages between doing it the other way. In other words, if you wanted an answer for what f of 1 is, just plug it in for x everywhere you see x and come up with a number. And then if you have a number 17, you got more information.
True.
Now, it didn't ask for what f of minus 1 was. So we probably don't want to do it that way. It actually specifically requested that you use the remainder theorem or synthetic division to evaluate the function. If they want an answer for f of minus 1, I would plug it in. That's the easiest way to do it. And you come up with a number.
Okay.
You see that? In other words, let's not drop this for a moment. We only got 2 minutes. Let's just do the math here. Minus 1. I'm curious as to how this number is going to relate to our synthetic division. The synthetic division told us that that was not a 0, but it didn't tell us what it actually was. I'm curious. Maybe we could figure it out. So this is minus 3 minus 1 plus 2 minus 2 plus 3. That cancels with that. That cancels with that. That was our remainder, was it not?
Yes.
Are you telling me that I didn't know this, that the remainder is your answer? Yeah.
Yeah.
I bet it is. I bet it is. So actually, I did not know that. But the fact that they asked you to evaluate it at that made me think that one of these two methods must give you the value of f of minus 1. And it looks like it was the remainder we got when we used, yeah, because if we'd have gotten a 0, then you could say that f of minus 1 is equal to 0. And that would be true. But in this case, it's always equal to whatever is in that last box. Huh, interesting. Okay. Taylor, I'll let you go, and I apologize again. You know, you can schedule half-hour sessions if you want a full hour on this material, and you want to just schedule another half-hour session. I got a lot of time this week. So,
Okay.
but if you're going on spring break tomorrow, you're probably not in need of it for a while. But anyway, enjoy your break. And
thank you.
I'll talk to you next time you need help.
Okay, sounds good. Have a good break.
Bye.
Bye.